Today we're in section 13.6, and we're writing equations in slope-intercept form. So that's really important, all right? There's a certain order that we have to write these equations, and we know that slope-intercept form is y equals mx plus b, okay? So that's going to be repeated several times throughout the lesson today. So here I have what? What do I see here in front of me on example 1? I see graphs. You do not have to copy down the graphs. If you remember back to the section on slope, all right, the section on slope when I needed to determine the slope based on the graph, does anybody remember what I did? In order to find the slope and all I have is a graph, I could count rise over run. Rise over run, okay? So rise over run from left to right could tell me the slope. And what I'm trying to do is I'm trying to figure out, well, I know if it needs to be in slope-intercept form, it's going to start with y equals. And then the mx plus b. Does anybody remember what m stands for in the equation? It stands for the slope. So can I use the graph to determine the slope? Yes. Absolutely. I can count rise over run to determine what m is going to be. All right, so let's start at the first point, 0, 2, right here, and let's count the rise. 1, 2, and what's the run? 1. Okay, so instead of the m, I'm going to write 2 over 1, or what else could I write? Just 2, right? Now, 2 over 1 reminds me it's rise over run. Either way would be fine. Now, does anybody remember what B stands for?
The y-intercept.
It does. It stands for the y-intercept. Is that also something that I could determine based on the graph?
Yes.
Yes, because where the line intersects the y-axis is where is going to be my B value. So at what y value does the line intercept the y-axis?
1. 2.
At a... 2. Yes. No, 2. Up here. Okay? Up here at a 2. So instead of a B, I'm going to write a 2 because that's my y-intercept. All right? And if it had been negative, I would just change it to a minus. Okay? All right. Now, let's see here. Okay, I want you to do the second one and notice something that's a little different about the slope here. You try to write the equation that is represented by that line on the second one. Okay, so slope, guys, focus up here. All right, the recording started. Stop. Okay, rise over run between the 2 points. 1, 2, 3, 4, 5, 6. Negative 6. Over 1, 2, okay? So I go y equals negative 6 over 2. Remember, the rise is negative, never the run. X. And then what is the y-intercept? Where does the line intersect the y-axis? Just tell me. Y equals 2. Positive 2 or negative 2?
Positive.
Okay, now this is only a partial credit answer because I need to reduce it. Negative 6 over 2 reduces to negative 3. Negative 3 x plus 2. Now, you could say negative 3 over 1. That would be fine also. All right, and no points off if you said 3 over 1 or negative 3 over 1. All right, so that's how I would write an equation from a graph. Is everybody clear on that? I can count my rise over my run for my slope, my m value, and see where the line crosses the y-axis for my y value, for my b value. Good? Okay. Now, still on example 1, what if instead of a graph, what if I only had a set of ordered pairs? So it is a true statement that I could take these ordered pairs and plot them on a graph. But by the time you plot them on a graph, I will be completely finished with this problem because there is a faster way to solve it when I have a list of ordered pairs. Aren't you guys kind of on board with doing it the fastest way, right?
No.
Okay, so we don't necessarily want, well, I enjoy graphing. Well, you might enjoy graphing, but do you want your homework to take you forever? No. Okay, so here's my advice to you, okay? Pull out 2 ordered pairs from the table. They have to be back-to-back ordered pairs, and include the ordered pair that has a 0 for the x value. That's actually pretty significant. We'll talk about that in a minute. So on the first table, that's going to mean the first 2 ordered pairs, because the first one is the one that has the 0 for the x value. All right, so I pull out those ordered pairs. 0, -3, and 3, 2. All right? You might be asking, well, why am I doing this in the first place? Well, remember, what's my end goal? My end goal is to fill in my equation, right? Well, when we learned our lesson on slope, we learned how to find slope from a graph and using ordered pairs. Does anybody remember the formula to find slope using ordered pairs? Kennedy?
If m equals y2 minus
Yep.
y1
Yep.
over x2 minus x1.
Very good. Over x2 minus x1. And do you guys remember the sequence in the ordered pairs? Do you guys remember the sequence? All right, say it with me if you remember. x1, y1, x2, y2. So what we're doing by doing all of these ordered pairs is we're trying to figure out what the m value is, what slope is. And I can do that by using 2 consecutive ordered pairs and plugging it into the slope formula. Okay? So, Noah, which one is your y2 value?
2.
Okay? And Jamie, which one's your y1 value? -3. So what happens, Xavier, what happens when you subtract -3? Yes, it changes to addition. Very good. All right, we'll do that in just a second. What about the denominator? What's that going to be? Just tell me. 3 minus 0. So we change our double negative to a positive. And 2 plus 3 is 5. So m equals 5 over what? 3. And you plug that in where m goes in the formula. Y equals 5/3 x. And now we have to use the table of values to figure out our y-intercept. Here's how I do it. I look for the ordered pair that has a 0 for my x value. Okay, that kind of erased it a little bit. If it has a 0 for x value, think about it. It's not going either way on x. I'm only going down to a -3 to plot that point. Think if you're plotting that point on a graph. You're not going to go either way on x, and you're going to go down to a -3, right? So that's where it intersects the y-axis. Okay? So the ordered pair that has x as a 0, the other value, that y value, is your b value. That value is your y-intercept. It doesn't go either way on x, and it goes directly down to a -3, and you plot your point there. That's where it crosses the y-axis. Okay? All right, I want you to try the second one now completely on your own. Remember, we're trying to fill in our m value and our b value. We can use the ordered pairs to find m. And really, guys, when you just even first look at this table, you should know what b is already. Okay, so it's just a matter of finding m. Let's go ahead and do it. Okay, pulling out our ordered pairs, we have -3, 3, and 0, -1. Okay, I had some people in my last class. Did anybody do 0, -1, and 3, -5? Did anybody do those too? Okay, a couple people. That's totally fine. So your numbers are going to look a little different at first, but then your slope will still be the exact same value. All right, so we go y2 minus y1 over x2 minus x1. All right, that becomes a positive. Okay, negative 4/3. Did you guys get negative 4/3? Negative 4/3. Okay, so y equals negative 4/3 x, and then what's my b value? How'd you know it was negative 1? Because it's paired with the 0 for x. And remember, if the x value is nothing in an ordered pair, that means I don't go left or right. I just go down to negative 1 and plot my point. So it's minus 1, and that is my answer. That's my equation. Example 2 is going to look familiar to you from some of our other sections, okay, because of the kind of line that it is. So we need to look at the graph over here and figure out which equation it matches with. I love questions like this because it makes us kind of think like why our answer is not one of the choices and what would be the choice. So before we talk about the equation that is the correct answer, I want to first eliminate at least 2 options that are not the answer and why they are not the answer. All right, so which one do you think, raise your hand, is not the answer? Okay, just give me one. Jason? Okay, C. Okay, so if why would that not be the answer to this graph? Because if y was on 0, what would be happening? Where would the line be crossing through? The origin, right? If y equaled 0, the line would be passing through the origin, which it's not. So it's definitely not C. Okay, which one also is it not? Isaiah?
B, y equals -3.
Very good. Why is it not y equals -3?
Because the point's not on -3.
Because the point would be on -3, right? And there's no point on -3, so it's definitely not B. Does anybody know what the answer is? Kayla?
A.
The answer is A. Why?
Because the point's on -4.
Very good. Because the point is on -4 and my line is going through a y value of -4. I know that's kind of sloppy, but do you see? The y is going through a value of -4, so that is the correct choice. Good job, guys. Good job. Now, you're going to have some exceptions. And what do I mean by exception? Well, here I'm going to give you a table of values, and I'm going to give you a graph. But in both of these, something different is going to happen in your slope. But we still need to write the equation that matches these values. Okay, so what I want you to do on the first one, number 3, is I want you to pull out 2 ordered pairs, find your slope and your y-intercept, and then go ahead and write your equation. You're just going to notice something different is going to happen. All right, so when we plot our ordered pairs, -4, 5, and 0, 5, we have y2 minus y1 over x2 minus x1. Did you catch the double negative?
Yes.
Okay, changes to a positive. And then we have 0 over 4. Wait a second, though. When 0 is in my slope, I can't stop there. I have to clarify. Does that mean my slope is 0 or undefined? Just tell me.
0.
It is 0. Undefined is in the denominator. Okay? So technically, my answer is y equals 0x. Well, if it's 0x, that completely cancels out that term. You don't have to write that. Okay, if you wrote 0x on your test, I'm not going to mark off at this point, but at some point, once you get into Algebra 1, Algebra 2, they're going to say, why are you writing a 0x? You just need to realize it cancels. All right, so technically, we should not write the 0x. And wait, why did I write a 5? Because it is the ordered pair connected to 0. Okay, and look at all your y values, guys. 5, right? So think about these ordered pairs. -4, left 4, then where do you go? Up 5. 0, up 5. 4, up 5. All of your points are plotted on a y value of 5. So when you graph this, it's going to be y equals 5. See that? No slope. It doesn't go anywhere. It's just 5s all the way across. All right? So, do you know how you could cut out all of that slope work? If you were able to look at this table and see that all of the y values are the same. Anytime you see that all of the y values are the same, think about it. Doesn't matter where you're going on x, you're going up to the same y value. That's a horizontal line. That's the slope of 0. Okay? If that just kind of went over your head, just find the slope. Just find the slope and then you'll see it. Okay? So what do you notice about number 4? What do you notice about number 4?
The denominators are the same. Wait, no.
No. What kind of line is it, guys?
Horizontal.
Horizontal. So if I'm reading a graph, think about this. If I'm reading a graph, remember, I need to determine my slope. So from the point on the left to the point on the right, what is my change in rise? What's my change in rise? Do I go up or down any?
No.
So my change in rise is 0, and what is my change in my run? 1, 2, 3. So my slope is 0 over 3. Y equals 0 over 3x. What's my y-intercept? Where does the line cross the y-axis? Plus 1. Now, remember what we said, though. Okay, I'll accept this answer on your quiz, but do we technically need this? No, because it's 0. It's 0x. So the better answer is y equals 1. Y equals 1. And you don't have to put the plus 1 because if there's nothing there, we know it's positive. All right? Does that make sense, guys, with those horizontal lines? Okay. So we have one more example. All right. Have you ever thought about what it takes to dig a tunnel like through a mountain? Think about it. I mean, that really is an incredible engineering accomplishment to literally drill a hole through a mountain that you can drive through. Think about it. Or underneath a river. You know, New York City has a tunnel that goes underneath the Hudson River. Subway. A subway. Okay. So, wow. I mean, how incredible is that? Like, literally. So, what kind of a machine would it take? It would take something like these. They're called tunnel boring machines. All right, can you see that picture on the right-hand side? Those tunnel boring machines literally activate and they spin to do exactly what it says. It bores a hole. So boring like that, it literally drills that hole through. Okay, it really is incredible if you think about it. Okay, you can tell that I'm kind of interested. All right, so... okay, so engineers are digging a 3,500 foot long tunnel. Before you think that that's like forever long, well, remember, 5,280 feet is a mile. So this isn't quite a mile. All right, so, but it's 3,500 feet long. And they're digging it at a constant rate. So that's important. When they say it's a constant rate, that means that we have a slope. Okay, so that's very important. After 4 months, the engineers still need to dig 1,500 feet to finish the project. So how much time would it take to complete the tunnel from start to finish? Okay, well, because it has been dug at a constant rate, that enables us to figure out how much they're actually digging per month. Okay, so don't try to answer the question. Don't get ahead of me. How many feet did they start at? 3,500. Okay. And how many feet were left at the end of 4 months? 1,500. Okay. So how many feet did they dig in 4 months? They dug. Does everybody agree? If they started at 3,500 and then they had 1,500 left, that means they dug 2,000 feet in 4 months, right? So I can divide it by 4 to figure out how many feet per month. 500 feet per month. Okay? Is this my answer?
No.
No. Don't shout the answer out because some of you already have your answer, I think. Okay? Think about it to yourself. If I'm digging at a constant rate of 500 feet per month, there's actually 2 ways that you could figure this out. From start to finish, how many months would it take? So once you figure out the rate, anybody want to raise your hand and give it a shot?
Do you want the months
Anybody?
all or how many?
I want total. I want total months. Miles?
7?
It is 7. How did you figure it out?
I just thought each 500. If you do 500 feet, it's 1,000. That's 2 months. And then 1,500. And that's added.
Okay, so what he's saying is, I knew that they already took 4 months, and I knew if they're going 500 feet a month, to go 1,500 feet, how many more months is that going to take? It's going to take 3 more months, so that's 7 months. Can anybody think of maybe even a more straightforward way of coming up with your answer, Noah? Yes. Okay, so you can go all the way back to the very beginning. You say, well, I don't know why I drew the arrow to digging, but if they're going 500 feet a month and they're going 3,500 feet total, 3,500 divided by 500, 7 months. Okay? Either way, you came up with your answer, and because it's a constant rate, meaning they didn't start off and then get tired or something. Like they were digging constantly, so we can use that rate to predict how long it would take. Good? Okay, so that's everything you need to know for 13.6.